Veracode tested over 100 language models across 80 coding tasks. 45% of the AI-generated code contained at least one OWASP top 10 vulnerability. None of it failed to compile. Your build stays green while the whole ships. So you scan for it. 5 checks, 60 seconds every diff. 3 reasons AI diffs need their own review procedure. 1. Models nail the happy path and guess at the error paths. That's what the training data rewards. 2. Wrong AI code looks exactly as confident as right AI code, so style stops being a signal. 3. Volume. When the machine ships 10 diffs a day, read everything carefully, stop scaling. You don't read harder, you scan smarter, in this exact order. Check 1. The scope scan. Before reading any code, read the file list. You asked for a null check. The diff touches 9 files. 2 renames, a reformat, a bonus refactor. Every extra file is a place a regression can hide, and none of them were reviewed on purpose. The tell is unrequested churn. Line counts wildly out of proportion to the ask. The fix takes 10 seconds. Compare the file list against the task, and if they don't match, reject before reading, resubmit touching only what the task needs. You're not reviewing code yet, you're reviewing intent. A diff you shrink first is a diff you can actually review. Check 2. The boundary check. Scan every line that crosses out of your codebase. Imports, package names, framework calls, external APIs. This is where models invent a plausible library, a method that should exist and doesn't. That unfamiliar import is not a style issue. It's a supply chain risk. Attackers register exactly the package names models tend to hallucinate. Green version. Every unfamiliar boundary name verified against official docs before merge. 30 seconds of docs beats an afternoon of build logs, and if the AI can cite the doc, make it do that in the PR description. Check 3. Read the error paths first. Skip the happy path. It's almost always fine. Catch blocks, else branches, timeouts, nulls. That's where AI fills silence with guesses. The empty catch, the debug level log, the default value nobody asked for. 1 question per catch. Handle, log, or rethrow. Which one is this? After, every error path either recovers on purpose, logs where someone actually reads, or rethrows with context. If last video's silent swallow is in the diff, this is the check that catches it in seconds, because you went straight to the catch blocks. Next one has the worst failure mode of the 5. Check 4. The security pass. 3 questions. Every diff. Question 1. Where does user input touch this code? Red version. A query built by string concatenation, an endpoint missing its authorization check. The classic AI shortcuts, learned from a decade of insecure tutorials. Question 2. What can this code reach that the user shouldn't? Models optimize for working code, not for least privilege, so the generated version tends to hold broader access than the task needs. Question 3. Any secrets, keys, connection strings in the diff itself? Green version, parameterized query, explicit auth check, secrets in config. 3 questions, 15 seconds each. Check 5. Demand the proof. The diff says done. Done according to what? Red version. A confident paragraph describing tests that don't exist anywhere in the diff. The rule this channel keeps coming back to. A claim without a failing test is a vibe. Green version. The test exists in the diff. You watched it fail. You watched it pass. If your project runs tests with 1 command, this check costs 10 seconds. If it doesn't, building that command is worth more than this whole checklist. The card, scoop scan, boundary check, error paths first, security pass, demand proof, 60 seconds, in that order, before any deep reading. It filters the predictable failures and tells you which diffs deserve real attention. Screenshot it, run it on the next diff you get. Which check would have saved you the most pain this month? Tell me in the comments. The 6 failure patterns this catches are the previous video, linked below. Subscribe for the next build.